Hello everyone. So today we are pleased to present you our research paper on gender and people monitoring system using YOLO. You look only once. And the authors for this paper is Mr. Ziad Piran and Dr. Rajmolu from the University of Mauritius. So to start with, let's have a look at our agenda. So we are going to have our aims and objectives, features, the architecture, the technologies used, the results, and our conclusion. So the project aims and objectives. So first of all, there is a retrieval and processing of human images from a publicly available dataset. Then the training of custom YOLO models using images from selected dataset using the darknet neural framework. And the aim is to achieve a maximum accuracy on the trained models, and implementation of the gender detector and popularity monitoring system using the FLOSS web application, and finally testing and evaluation of the system. And as you are aware, YOLO is a new framework for detections, and so that's why we are trying to test that framework on gender and people monitoring systems. So in terms of the system features, we'll try to perform a real-time gender detection using the custom YOLO V3 model, so the latest model, and then perform real-time gender detection using custom YOLO Tiny model. So we can upload an image or a video to perform gender detection using custom YOLO V3 model, and also detect, track, and count the number of people entering, leaving a room, building using the popularity monitoring module. So that's in terms of the feature. And in terms of the technologies that we have used to implement such systems, so first of all we have YOLO, OpenCV. It was done on Linux, both Linux and Windows platform. So we have been using Python and FLOSS framework for web-based application to communicate with YOLO and OpenCV libraries, Colab, Google Colab, Anaconda, and Darknet. So our system architecture is as follows. So we have our main system, which is a gender detection and popularity monitoring system. So what it does, first of all, there is the video capture module, whereby it's going to query frames from either the webcam live feed, IP camera live feed, and downloaded videos. So we have a module of video capture to have these input. Then we have a processing module which detect and classify people according to their gender, count the number of people, and compute their direction. So this is based on the custom YOLO V3 model and V3 Tiny models, which help us to detect and classify people and count people. Then we have the people tracking, and this is done using Centroid tracking system to count the number of people and compute the direction. And finally, we have our interfacing feature, which we are using a web browser. So as compared to other systems, here we are, as interface, we have a web browser which can be used to take input from webcam, IP camera, and download videos, and then do the processing to display the results, as compared to previously known systems whereby it was only desktop based, because it was mainly stick to OpenCV and other APIs, so that they were not web enabled. So here we are using the web browser, especially through the FLOSS framework that allows us to interact with OpenCV and the YOLO library. So in terms of the implementation workflow, so first of all, we have the database retrieval and preprocessing, which we do. So we have downloaded open images, version 5 and CSV files. So we retrieve those information and corresponding annotation from the dataset, and batch retrieve, resize the images. Then lastly, we split the dataset into training and testing. All these, they are from the open images dataset. Then these datasets are clean and stored on Google Drive, and intermediate YOLO weights are assigned to them. So in terms of training configuration, so we have so git clone .NET framework from GitHub. So we upload the .names, .data, and .csg file. We download pre-trained weight files, and we launch the training. All these are done on Google Colaboratory. So just to get the intermediate YOLO weights, and based on the web application, so this is a link to our interface web application, whereby we have the option of getting images or videos from either live stream, IP cameras, and uploading models. So once we get that, then detection starts. So the model is being deployed on our web applications, so that we can start detecting and classifying gender and tracking. So in terms of the results we obtained, so we have been working on YOLO v3 and YOLO v3 Tiny. So in terms of the mean average precision, so as seen on the snapshot here, so usually for YOLO v3 it's around 96.9% for women, and men it is 97.69% for men, compared to Tiny, which is a bit less accurate. So for women it is 60.36, and for men it is 84.21%. And in terms of mean average precision, so for YOLO v3, so you have 0.97, and for YOLO Tiny it is 0.72%. So we have been testing the scenarios. So we have been having the test case scenarios and the different conditions. So in terms of the accuracy, so especially if you are looking at the hidden hair, whereby, for example, you have a woman wearing the hijab, so it detects it at 97% accurate. So hidden faces, whereby pictures are taken from the back, okay, so for men it is 94.2%, and women it is 91.6%. Under normal light condition, so we have 90% for men and 93% for women. Low light conditions 82.4 and 84% for men and women respectively. High brightness conditions, so here the accuracy decreases a bit, whereby for men it's around 70% and for women it is 77%. Black and white condition, again, so more or less the same condition as the brightness condition. So group detection under normal light condition, so here for men it is around 89.5% and women 87.2%. And for crowd detection under normal light condition, it is 70.5% and 72.7% for women. So these are the test case scenarios we have been looking at, and it performs rather well under these different conditions. So to conclude, we'll say that the development of this vision-based gender detection system proved to provide conclusive results. So deep learning and computer vision technologies have been aggregated to provide both detection and tracking abilities into a single system. So implication of such system can improve the capabilities of a surveillance system to detect stampede, improve inventory management through analysis of customer demands, and enable robots to discern the dissimilarities between male and female. So unlike other systems, this system gives the ability to choose between YOLO v3 and YOLO Tiny, as well as being a pure web-based application as compared to normal applications which are only desktop application. And being a web-based application, so you can open up the system to anyone using it, so from anywhere in the world. So just to upload their pictures or connect their live stream, and the system is going to uh, do the different categorization and analysis of the images and provide the results. And the system, as said, the system accomplishes both detection on uploaded pictures and live streams while offering the least amount of processing time. So these are some of the main achievements of our system. And as future work, we are looking at to deploy it on a larger scale, so that to be able to test the robustness of the system. So that's all, and thank you very much for your attention. Thank you.